Hi people, and welcome to the calculus section of the Mathematics Paper 1 for May-June 2026. Okay, so question 7.1 says, determine f prime of x from first principles if it is given that f of x is equal to x squared plus 2x. Okay, so something we can do is just use the rules of differentiation to actually just find it here. And then that way, once we get our final answer, we will know it's right. Okay, so if we're finding the derivative here, we say f prime of x is equal to, and you'd say the coefficient of this expression times its exponent, which will give us 2. Okay, so 2x, and then exponent minus 1 is 1, but you don't have to rewrite that 1. And then we have positive 2, so 2 times the 1. And then again, the x has an exponent of 1. You say minus 1, it gives you 0. Anything to the power of 0 is 1, and 2 times 1 is just 2. Okay, so at the end of the day, we need to get this as our answer. Let's go. So to use first principles, we're going to need this part, okay? The second y value, which is just going to be f of x plus h. Okay, and so we'll say this is equal to, you see how we just said f of x plus h. So wherever you see x, okay, you're just going to replace it with x plus h. And so this is equal to, there's x squared, so we'll say x plus h all squared plus 2, and then there's x, so x plus h. And distribute. So I'm going to say the first term squared gives me x squared. Last term squared gives me positive h squared. Then first term times second term, that gives us xh. Then you just multiply this by 2, which gives us positive 2xh. Okay, and then distribute here, we have positive 2x and plus 2h. Okay, so we have the f of x plus h. And now we can go ahead and write down our formula. So this is f prime of x is equal to the limit as h approaches 0, and then we have f of x plus h minus f of x, and then all over the h. Okay, so we substitute now, we say the limit as h approaches 0, and then you're just going to take all of this and then put it in. And you see how we are subtracting by something that has more than one term. So you're going to use brackets to ensure that that negative applies to both terms. Okay, so x squared plus 2x all over h, and then distribute. So the limit as h approaches 0, and we're going to take all of that again. But now when we subtract, we're going to get negative x squared and then minus 2x. And then this goes all over the h again. Okay, so what will cancel would be whatever is common with this, whatever you are subtracting by. So we have a negative x squared and a positive x squared. You see how they just become 0. And then the 2x minus 2x is also 0. And so all that is left is we say the limit as h approaches 0. And we have 2xh plus h squared plus 2h all over the h. Okay, and so now do you see that we can take out a common factor? So the whole point of this is we are finding the limit, okay, as h approaches 0. But at this point, a direct substitution will make the denominator equal to 0. And so that's what we're trying to do, to get this h out of the denominator, and then that way we can actually find that limit. Okay, so again, the limit as h approaches 0, and we're going to take h out as a common factor, and then we have what is left in the first term. You can just say first term divided by that. Okay, it gives you 2x. And then second term divided by h, again, it's positive h, and then we get positive 2 here, all over h. Okay, so now these cancel, and now we can finally find that limit. So I'll just write this one more time. F prime of x equals the limit as h approaches 0, and then write this down. But then now we can substitute. So when you're substituting, you do not have to write this limit again. So now finally f prime of x is equal to 2x plus 0 and then plus 2, which is just equal to 2x plus 2. Okay, so you see that we actually do get to this same answer that we got to when we just used the rules. Okay, moving on to the next question. The next question, we have to find the derivative of this function. Okay, so we're saying f prime of x is equal to, and using the rules, we say coefficient times exponent, we get 2x, exponent minus 1 is 1. And here we'll get negative 1, okay, multiplied by the exponent of 1, which gives us negative 1, okay. And then the x is going to fall away. Remember, exponent minus 1 becomes 0. Anything to the power of 0 is 1. Okay, and then the negative 6 is a constant. It will fall away. Because the gradient of a constant is 0, okay? You're just saying a straight line, like y equals 5, okay? The gradient of this line is simply 0. Okay, so that is our answer. Moving on to the next question. Next, we have to find the derivative of this function. So, because we are not ready to derive yet, clearly you can see that this is still under a cube root, and then this x is in the denominator. We need to fix those first. So, we're going to have to bring those up. And until we are ready to derive, until we are deriving, we can't stop writing that. So, this is d over dx. And then we have the cube root of 27. That gives us 3. Okay, so we have 3 there. And then the cube root of x to the power of 4. You see, you have x to the power of 4, and then there's a cube root. To rewrite this so that it's no longer a surd, okay, but just an expression with a rational exponent, you're going to rewrite it like this. You leave the x, and then you're going to say the inside exponent over the outside exponent. So that is just going to be a 4 over 3, and we'll write it like that. Okay, so that is simply just x to the power of 4 over 3. And then we have this one. Okay, the only problem here is that the x is in the denominator. So we're just going to move it up. So it's going to be positive 2, and then we have x. But now when you push it up to the numerator, then what's going to happen is the exponent becomes negative. And now we are ready to derive. Okay, so we can just say is equal to, and then let's go. We're going to say the coefficient of 3 times the exponent of 4 over 3. Do you see what would happen here? Okay, this 3 is in the numerator. It has a natural denominator of 1. So these 3's cancel, and you're just left with the 4. So it's a 4 here. And then, remember, exponent minus 1. So this is 4 over 3 minus 1, which can be expressed as 3 over 3. Okay, and so you're just saying 4 minus 3 is 1. So that's 1. And then the denominators stay the same. Okay, so this is x to the power of 1 over 3. And then the next part, we have 2, okay, the coefficient times the exponent of negative 3. That will give us negative 6. And then we have x. And you're saying the exponent minus 1, which you can see will give us a negative 4. And this is our answer. Moving on to the next question. Question 7.3 says the graph of k of x is equal to 2x to the power of 3. So this is a cubic function where the coefficient of x cubed is positive. And then do you see how they don't give us anything else? They say that this function has turning points at x is equal to negative 2 and x is equal to 0. We need to determine the values of k for which, and the first one is k prime of x is equal to 0. Okay, so with this one, we don't even really need a graph, okay? I'll probably use a graph in the other ones, but then for this one, it's not necessary. Think about this. You have k of x is equal to this, right? A cubic function. So if you have some cubic function, this one, okay, its a value is positive. So it's going to look like this. It looks like an n, okay, but just more curved. So kind of like that. If you derive this function, because they say k prime of x, okay, what are you trying to find? You're trying to find the gradient of this function at any point. Now, they specifically said k prime of x is equal to 0. Meaning now you're trying to find where the gradient of this function is equal to 0. Okay, a cubic function has different gradients at different points. So over here, for example, if you have to draw a line, okay, or really a tangent to that graph, do you see what this line is doing? How it is increasing. If a line is increasing, it means it has a positive gradient. Okay, if we move this point all around, so you just keep moving it, maybe I just tilt it slightly, you see that it could be a tangent to the point over here. And then it still has a positive gradient. If I keep moving it, okay, throughout this graph, look at how it is tilting now. Then once I get it to the turning point, look at how it's going to sit, okay? So this point is where your gradient, do you see how flat this line is? When you have a horizontal line, a flat line, this is where the gradient is equal to 0. The gradient will always be equal to 0 at the turning points, okay? So there and there. The gradient will also be equal to 0 here. The tangent to that line would be a horizontal line. So from this, you should know that k prime of x is equal to 0. This happens at the turning point. And do you see that they already gave you those? Okay, so I'll leave this on the side and we can just put down our answers. Okay, where k prime of x is equal to 0, this is where x is equal to negative 2 or x is equal to 0. And that's our answer. Moving on to the next question. And then the next question says we need to find out where the second derivative is less than 0. Okay, let's speak about second derivative. If they say the second derivative is greater than 0, this is where the function is concave up. And then when it is less than 0, okay, when it's negative, this is where it is concave down, okay, and that's really just it. So looking at this graph, okay, with this, we're going to have to see where is it concave down, okay. Let me go ahead and bring this over here, and I guess we can just give it some sort of, like Cartesian plane, just so that we can just reference where these are. So I know that one turning point is at 0, okay, and then the other one is at -2. Remember, from the way this is, if you look at x is equal to -2 and x is equal to 0, which one would be on this side, okay? Because if you're looking at an x-axis, then you know that points that are more to this side, they are less, okay? So we know that here, that's where we're going to have the -2. The -2 will be this side, okay? And then the 0 is on the other side. Okay, so the way I drew it, it shouldn't look like this. Okay, maybe we'll just have this over here. Okay, so then that would be -2 here and then 0 here. And so our y-axis would just be here. Okay. Okay, so this is the -2. This is the 0. Where is it concave? Down. Okay. Now I know you're looking at it and saying, but if it's going to be concave down, we can see where it's concave down. But then how do we actually find this? We can see that this is where it's concave down. Do you see how it looks like a sad face parabola? Okay. And then this is where it's concave up. It looks like a happy face parabola. But now how do we point out where this is? Where does it start? Okay. So where the concavity changes is at the point of inflection. So how do we find that point with what we have been given here? Something you need to remember about a cubic function is when you derive it, okay, it's going to create a parabola, because when you say k prime of x, you need to say coefficient times exponent. That's going to give you a 6, but then you're going to say exponent minus 1, which gives you a 2. This is going to be the highest exponent here, and it's going to create a parabola, and you can see the coefficient of that parabola was 6. It's going to be a concave up parabola. Now, that parabola, when we draw it, you see this 2, this -2, and the 0, they are going to be the x-intercepts of our parabola, okay? This is where k prime of x, the parabola, okay, is equal to 0, where the parabola's equation is equal to 0 at these points, okay? Now, the point of inflection, that is going to be whatever the x value of this parabola's turning point is. So do you see how it's something we can actually find? If you were given a parabola and you were given one x-intercept and another x-intercept, how do you find its turning point? Okay, the x value only, not really the y value. You'd simply just say, I know that that turning point is going to be right in the middle of my graph because the parabola is symmetrical through its turning point. So whatever this part of the graph does, this part of the graph does the exact same thing. And so it means that this is the halfway point between these x-intercepts. So if you find out what the midpoint of this is, you have found that point of inflection, okay, the x value of the point of inflection. So we can simply just say to find that point, we're going to find that x value of the point of inflection, and you find this by saying the -2 plus the 0, okay, x1 plus x2 over 2 to find that midpoint of the x values. So x is just equal to -1. Okay, so we know where that is. And so where is it concave down? If you know this is -1, do you see that all these places, look at all the highlighted places, if you line all of these down to the x-axis, it's speaking about all these values that are simply just less than -1, to the left side of -1. And so finally our answer is just x is less than -1. Okay, moving on to the next question. Okay, next question, and I'm just going to remove the parabola because we really just need the cubic function, okay? Whenever they ask for these k primes, we just need the cubic function. I don't want to depend too much on the parabola because it's not really necessary to do that. I want you guys to understand that every time they say things like k prime, it's really just speaking about the gradient of that function, okay? And then you have to look at what is that function doing at that point to determine the type of gradient that it will have. Okay, so this question 7.3.3, the last question for calculus question 7 is k prime of x, where is k prime of x minus 3 greater than 0? So this is very similar to k prime of x being greater than 0, but this time they've said minus 3. So remember, when you are adding or subtracting to an x value, remember what you're doing to this point, okay? You are either shifting the point to the left or to the right. Up and down movements only affect the y value. So if this point was 1 and 2, and I needed to shift it 3 units to the right, do you see how it's going to become? I'll move 1, 2, 3, and it's going to become 4 and 2. Only the x value will change because adding or subtracting to the x value will shift the graph either to the left or the right. But now, do you see that they say x minus 3? So if we're subtracting by 3, okay, when you minus from an x value, you are actually shifting it to the right. When you say plus, you're actually shifting it to the left. So this works with the equation, okay? So if you see x minus 3, then it means they're actually shifting it to the right. So we can see that there. So this is where k prime of x is greater than 0, but this time they shift that to the right, okay? So think about what k prime of x meant. K prime, okay, if the graph of k of x is whatever it is, then k prime would be the gradient of this function at any point. So they're saying the gradient of the function is greater than 0. In other words, is positive, okay? Remember what positive gradients look like. If a line has a positive gradient, this line would look something like this. This line is increasing, okay? It's going up. This is a line with a positive gradient. So if the gradient is ever positive, then just know that these are the places where the graph is increasing. So let's just look at what they mean here first. Where is the graph increasing? Then we'll speak about the minus 3. Okay, I'll just mark that. That was just the point of inflection. Now, where's the graph increasing? Let's look at what the graph is doing all through. You read graphs going from the left-hand side to the right-hand side. So if you follow this graph, look at what it's doing. It is increasing. That's what we want. Then it stops increasing, okay? It stands still at this point, and then it starts decreasing. And then it reaches a turning point again, standstill, and then it starts increasing. So we can see that the places where the graph is increasing would be here and here, okay? Now what they have done is they didn't just say k prime of x is greater than 0. They said k prime of x minus 3 is greater than 0. Remember what this does. Minus 3 will shift the graph to the right. It will shift it 3 units to the right. So you see these parts that we have marked? We can see the whole graph as it's going to just shift 3 units to the right. And then that is it. So if this shifts 3 units to the right, then do you see that the turning point will now be where? Okay, if this is negative 2 and it moves 3 units to the right, negative 2 plus 3 is positive 1. So this should now be positive. It'll look like that. So here, the turning point is now a positive 1. And then what is the other turning point? Remember, this one was x is equal to 0, okay? But now it's going to be 3 units to the right, so x is equal to 3. And that's it. And still, you're still looking for the places where it's increasing. You know that's here. And you also know that is still here. And so now you can tell them your answer. So we can see that it's increasing all through here. To tell them what those are, remember it keeps going like that. So it came from being really low and then it was increasing, and it came like that. So to understand these x values, you can simply just line them to the x-axis and then you'll see. So line them down to the x-axis just to understand. These are all these x values and they will keep going to this side, okay, the left-hand side. So do you see that they are all values that are simply, if we know that this is 1, okay, it changed to 1. If we know this is 1, this is where x is simply less than 1. And then here, okay, these ones, these are values that are simply greater than 3, okay. 1 and 3, they will mark the places where our solutions start because this is our turning point. So the gradient here is equal to 0. And then here, the gradient here is positive. Okay, so this is where x is less than 1 or x is greater than 3. And then that will be our answer. Okay, so finally here, x is less than 1 or x is greater than 3. You can, of course, also write this in interval notation and it will be x is an element of. Here, you're just saying we are coming from negative infinity and then stop at, not at 1 exactly, but we'll say negative infinity to 1. Okay. And we use a round bracket here because infinity is not a fixed point. And then 1, we also use a round bracket because we're just looking for where that gradient is greater than 0, not greater than or equal to 0. At 1, the gradient is equal to 0. And then here, or, and again, you're going from 3 and you're heading to positive infinity. And so that is just where you can say union, okay? 3 to positive infinity. And then there we go. Okay, also a round bracket for the 3. It doesn't say or equal to. So that is our answer. And that is it for question 7. We are now on question 8. And question 8 says, the graph of h of x is equal to, and we have negative 1 x to the power of 3. So this is already complete. The only things missing are p, q, and r. Okay, just like the previous question. And then they say that this graph is drawn below. And then we have this point C, and we have D, that these are x-intercepts. And then B is a y-intercept. Okay, it's the y-intercept of H. And then they tell us that A and C are turning points of H. Okay, they like to use this one where one of the turning points is also an x-intercept. Okay, so 8.1, they say show that P equals 9, Q equals negative 24, and R equals 20. Okay, so it's this. You see, with these questions, with cubic functions, when you're trying to find the equation of a cubic function, you have to look at the type of cubic function they gave you and also look at the information they've given you so far. This is that type of cubic function where you have one of the turning points being an x-intercept as well. Okay, those ones have a specific equation if you are looking at, for example, their x-intercepts. Now, do you also see that the points they have given you are the x-intercepts? Okay, these ones are not new. It's kind of like with the parabola. We also had questions like this in the parabola. With this one, to find the equation of this function, we can use this formula. You say A multiplied by, and this is just the x-intercept format of a cubic function. But now we have to take into account that this is the one where one turning point is also an x-intercept. This looks like this. We say x minus x1 all squared. Now, the one that gets squared, okay, is whichever x-intercept was also a turning point, and then multiply by x minus x2, okay, and then that will be the other x-intercept you have. Okay, so now we can go ahead and fill this in. So I'm just going to call it h of x. You can see here that they've given you the value of a, okay, it's in the form of ax to the power of 3 plus bx, okay, squared, and so on. So a is already equal to negative 1. Okay, so finally we can just say h of x, we'll say h of x is equal to, and we have negative 1, okay, multiplied by x minus, and our first x1 is that 2, that x-intercept of 2, that is also a turning point, multiplied by x minus 5. Now, do you see how your equation already looks complete? Okay, there's no missing variable. It's not like you have a missing or anything missing. All you have to do is distribute and get your answer. So this is h of x is equal to, and because this still has to be simplified, I'm going to put this one first. So it's negative, and then I have x minus 5. And now let's work with this. So I'll square the first term, it gives me x squared. Square the last term, it gives me positive 4. And then first term times second term, that's a negative 2x. And then you multiply this by 2, which gives us negative 4x. Okay, so this is what we have. And now we say h of x is equal to, and now we can finally distribute. So the binomial times the trinomial, that's what we're going to multiply first. So we have the negative outside, and then you're going to multiply. We get x to the power of 3, and then that will give you negative 4x squared, and that gives us a positive 4x. Okay, and then we're down to the first term. Now negative 5 times the x squared is negative 5x squared. And then negative 5 times the negative 4, that's positive 20x. And then lastly, these two give you negative 20. Okay, it's best to just simplify what is in the bracket first, just so that you don't make mistakes. So this is x to the power of 3. And then we have these two, okay, they're like terms. So they become negative 9x to the power of 2. And then these ones are like terms. They will just become positive 24x, and then lastly, the constant negative 20. And now finally, multiply the negative in. So finally, h of x is simply equal to negative x to the power of 3 plus 9x squared minus 24x, and then plus 20. And now just verify that it's all correct, okay? So you have the positive 9 being P, you have the negative 24 being the Q, and the positive 20 being R. Okay, so there we go. That is our answer. Moving on to the next question. The next question says write down the length of OB. Okay, so let's just look at OB. O to B, okay, that's from the origin to B. So if you know what B is, then you know what OB is. Okay, so B, this is the y-intercept of this function. And you find the y-intercept in the equation of the function by looking at the constant term. Okay, because remember, the y-intercept, this is the point where x is equal to 0. If you make x 0 here and x 0 and here and x 0 here, all of this just becomes 0. Then you just have the plus 20. Okay, so we know what B is. I can just conclude that that point B is simply just 0 and 20. Therefore, O to B is exactly 20 units. And that's our answer. Moving on to the next question. Next question says calculate the coordinates, okay, the full coordinates of the point of inflection of H. How do you find the point of inflection? The point of inflection will occur at the point where H double prime of x is equal to 0. Okay, this is where we will have the point of inflection. So that's really what we're going to do. We'll take our function, we're going to derive it, get the second derivative, set it equal to 0, and then we will find the x value of the point of inflection and then the y value. So this is what we have, and we'll just say h prime of x is equal to, that will give you negative 3x squared, positive 18x, and negative 24. Okay, the rules we've been using all through here. And then h double prime x is equal to, we get negative 6x and then plus 18, and the x falls away. And you're just making this equal to 0. 0 equals negative 6x plus 18. Take the negative 6x over, it becomes positive 6x is equal to 18. Divide both hand sides of the equation by 6. And finally, x is simply equal to 3. So this is the x value of your point of inflection. So if you know that the point of inflection will be found where x is equal to 3, how do you find the y value? Well, it's a point on the graph. So just substitute that x value into the equation of your function to get the y value that goes with it. Okay, so just do that. So this is our function. We'll take this and then substitute 3 into this equation. Okay, so h of 3 is simply equal to 2. Okay, and so these are our coordinates. The point of inflection is 3 and 2. And that is our answer. Moving on to the next question. The next question, 8.4, says, determine the equation of the tangent to H that has an angle of inclination of 96.34 degrees and touches H between B and C. Okay, they've given us a lot of information about this tangent, this line. Remember, a tangent is just a straight line. So at the end of the day, you're just trying to find the equation of a straight line, which you know is in the form of y equals mx plus c. So you need the gradient of this line, and you need something to help you find c. It could be the actual point c, okay, the y-intercept, or it could just be a point. You find a point on the graph, and then it will help you find c, okay? So as long as you have the x and the y value of that point, you're fine. So let's go ahead and see what's going on here and how this is formed. So between B and C, we're going to have a tangent with an angle of inclination of 96.34. So here is B and there's C. Okay, so between these, we're going to have a tangent to this graph. Okay, so first note that that angle is 96.34 degrees, right? 90 degrees would mean, like, for example, you won't find any point that will ever have a tangent to it at 90 degrees because a 90-degree line is a vertical line. Okay, so if you know that if you have a straight line, right, this is 90 degrees, so 96 degrees would just be slightly tilted, like something like that, right? And then this is a tangent to this graph. So I'm just going to have to maybe do something like this. Maybe it's over there, okay? So this is the point where it simply just touches the graph just once there. Okay, so it does not cut through the graph like what this one is doing. It just lightly touches it like that, just at that point. Okay, so it just makes contact with it there. And what they're saying is that this line, okay, it has an angle of inclination of this angle, 96.34. So that just means that, remember, you find the angle of inclination of a line by measuring from the x-axis to that line. So when we measure from the x-axis to that line, it forms 96.34 degrees. This is what they're just referring to. Okay, so they've given us information to find the gradient of this line because you know its angle of inclination. So how do you find the gradient of a line when given the angle of inclination? You use this equation, tan theta is equal to the gradient. Okay, so we have tan theta equals m. So we're trying to find that gradient, and so we'll say the gradient. To find the gradient, we say tan of that angle of inclination, which we know is 96.34. So 96.34 degrees, and let's find this angle. Okay, on your calculator, remember you're not saying shift tan, it's just tan 96.34. And then do you see what it is? Okay, I expect it to be a negative because that line would be a decreasing function. Okay, it's going down. So the gradient of this line, okay, rounded off, it's really just -9. That's the gradient of that line. So you can show them first that, hey, this is what I got first, and then just tell them, therefore, my gradient is simply just -9. Okay, now that we have the gradient, we just need 1 point on the line, and then we can find C. Okay, so we have the gradient. How do we find a point on this line? The thing about this line is they haven't given us any other info except for we found the gradient. But then do you remember that they said it's a tangent to H? So if we could just find out where it makes contact with H, then we have a point on the line. So how do we find this point? Well, the only thing you know about this line is that its gradient is -9. Why don't you find out where this cubic function has a gradient of -9? Okay, at which point is its gradient equal to -9? So remember, you're trying to find where the cubic function has a gradient of -9. How do you find the gradient of the cubic function? That cubic function h, you find its gradient by saying h prime of x. Okay, this is the gradient of the cubic function, which we already have. We have h prime of x, which is all of this. So this is the general gradient. This is the gradient of our cubic function at any point. But now we specifically need where its gradient is equal to -9. Okay, and now do you see how this creates this equation that we have? So I'm going to take this and I'll just go ahead and take all of these over. And we have 3x squared now, and then minus 18x, and then positive 24. And then this is still on the left-hand side, so it stays -9 is equal to 0. Okay, so we have 3x squared and minus 18x, and then subtract there, which will give us a positive 15 is equal to 0. Okay, now do you see that all through we have a common factor of 3? Okay, so we can just divide both hand sides of this equation by 3. Okay, so we're going to get x squared, and then 18 divided by 3, we get -6x. Okay, and then there, positive 5 is equal to 0. And now we need to factorize this. Okay, so to factorize these, we'll just open up two brackets, equate to 0. X multiplied by x is x squared. And then we need factors of positive 5. Okay, so what times what gives you positive 5? Well, you can say a positive 5 times a positive 1, or -5 times -1. But do you see how the middle is negative? So it can't be the positive and the positive, because then everything should be positive. So it's the negative and the negative. And so you know that -5 minus 1 also gives you -6, which is really the coefficient of your middle term. Okay, so this is -5 and then -1. Okay, so here x is simply equal to 5, and here x is equal to 1. Okay, so it means that we have 2 points here, okay, on this graph where the gradient is -9. So the other one is probably just a point like, somewhere there. You just touch the cubic function at one point, okay? So they already gave us a hint. They told us that it is specifically the tangent that lies between B and C. So which x value here between 5 and 1 would be in between B and C? That would be the 1. Okay, so we know that this one is actually just 1. I know it's not drawn to scale, so it looks funny. Okay, my line is not drawn to scale. I just drew a rough sketch. So 1 is what we're going to take. We're not going to take this. Okay, so we're not going to go with this one, but we're going to go with that one. So the x value that they're referring to is x is equal to 1. And now that we have the x value, we can find its y value. Because remember at this point, it still lies on the cubic function. So find out at what y value do we have an x value of 1 on the cubic function? Okay, so we just need h of x. And so I'm just going to take this equation and substitute 1 in here. And when we substitute 1, we get 4. Okay, so the y value is 4. So that point of intersection is simply just at 1 and 4. That's where the graph of h intersects with that tangent. Okay, so now we have the gradient, and we also have a point of intersection, or point on that line. So we can actually just use this to find the equation of the tangent. So we can say y is equal to, or you can say y equals mx plus c, but I'll just use this formula. Y minus y1 is equal to the gradient times x minus x1, and then y minus, and then we're saying 4 is equal to, our gradient was negative 9, then x minus 1, and then just simplify. So we have negative 9x, and then that becomes a positive 9. The negative 4 comes over to become a positive 4, and then we have y is equal to, and say y equals negative 9x, and then that is plus 13, and that is our answer. Okay, so that is it for that question, and that was the last question for question 8. So now moving on to question 9. We are now on the final question for the calculus section, okay, for this video. And it says, okay, so let's just start with the first one. They say the oxygen content in water T days after organic waste was dumped into a lake can be represented by this equation. So this is just checking the oxygen level after waste was dumped into some lake. So you can expect that the oxygen level will drop, okay, once you drop waste into it. And we are going to monitor it for 0 to 15, okay, so 0 to 15 days. What was the initial, and then I say 9.1, what was the initial oxygen content in the lake at the time the organic waste was dumped? So the initial oxygen content when the waste was dumped, think about it like this, okay? We are monitoring the oxygen level from 0 to 15 days. On the day that the waste was dumped into this lake, then this would be day 0 because no amount of days have passed yet. Okay, we can't call it day 1 because then you're saying 1 full day has passed. So we're simply going to take this, and this is specifically where t is equal to 0. Okay, so t is equal to 0. You can already see here that t stands for the, x values. So when you're making x equal to 0, you're trying to find the y-intercept. But it's fine. We can simply just substitute. So we'll just say all of that. And then I'm just going to substitute 0 in place of t. Okay, so do you see that we just get 1? So c of 0 is equal to 1. We're measuring the oxygen level. And do they give us a unit of measurement? Not really sure how oxygen is now measured. Okay, well, since they just say what is the initial oxygen content, then depending on how you're measuring it, it's just going to be 1 unit of that. I'm just going to call it 1 unit. It's fine. Okay, moving on to the next question. Then question 9.2 says, when will the oxygen content be at the lowest level? So be at the lowest level. Another word for lowest would be minimum. So we're looking for the minimum value of the oxygen content of this C of T. Okay, so how do you find that minimum value? This is already pointing at, derivatives and stuff. So we can just look at this equation. Okay, it's 1 over 1,200. And then if you had to kind of multiply in, you see this is still a positive number. If you multiply that, you get a positive number. So at the end of the day, this is a cubic function, but it's that type of cubic function where the coefficient of, in this case, t to the power of 3 is positive, okay? So it's going to create this type of cubic function, like the ones we worked with. Okay, in the previous question, that was question 7. And so this, okay, is a representation of the different levels that the oxygen gets, but specifically from t equals 0 all the way to t equals 15. Okay, so a rough sketch of this, we do know what the y-intercept is because this is where x is equal to 0, okay? So at 1 unit. So it will look maybe something like this, okay? When we're measuring it, we're going to see a situation where 1 was our y-intercept. So I'm just trying to make that hit 1, okay? So at x is equal to 0, maybe it reaches 1 here. And you're just measuring this thing, okay? From 0 to 15, wherever 15 is. Okay, so let's say 15 was like somewhere over here. Okay, you're just measuring, and we're saying what is the oxygen content at the lowest level. So that would be, we'll be looking for the local minimum. Okay, this would be at the lowest level that it reaches, and that would be the highest level that it reaches. Okay, when we find the Y value that belongs to that point, you'd be able to find out what exactly that level, that unit level was. Okay, so let's just find that minimum. We're trying to find the local minimum. And so to find this, remember the idea, we're trying to find a turning point. So you're going to take the equation of C, right? We're saying C prime of T. Okay, let me just actually get C out, because right now, they put the constant in front. So let's rewrite that first. And so we can just distribute in. This is just going to give us, we're just saying 1 over 1,200 t to the power of 3, and then multiply, that's just going to be 15 over that. I'm just going to multiply all of these out, okay? Okay, and then after the last one, do you see that if you just multiply these two together, the numerator and denominator would just cancel, and then that would be plus 1, see? And we would have seen that the y-intercept is actually just 1. So this is what we have, and we need to find that lowest level. So you're first going to derive this. You're finding the gradient at any point, but then you want specifically where the gradient is equal to 0, okay? So we're just going to say this and then multiply. Coefficient times exponent in this case, that is just going to be 3 over 1,200, okay? Because that's in the numerator. So it will be 1 over 400 t, and then you're saying 3 minus 1, which is 2. And then what is, you say negative 1 over 80, okay? Times 2, which is negative 2 over 80. And that gives us negative 1 over 40. And then we have t, 2 minus 1 is just 1. And then the constant will fall away. So this is what we have. And we're trying to find out where that gradient is equal to 0, because that's going to pinpoint the turning points. And then we have 1 over and then 400 t squared and minus 1 over 40 t. Okay, so we have t squared, we have t. You see that we also have a common factor all through. Here, we know that 40 in the denominator, okay, it can go into 400. So what I can do here is just take out 1 over 40 as the common factor and a t as well, and then open the bracket. If you say this divided by this, okay, you're just saying the 1 divided by the 1 gives you 1. The 400 divided by the 40 gives you 10, and then you have t squared divided by t, which is just t. And then here, do you see that this is just the same thing, just has a negative. So this is just minus 1. Okay, so now let's solve for t. So you're saying something times another thing gives you 0. The only way this is possible is if the first one is equal to 0, okay, or the second is equal to 0. Okay, so here, just divide both hand sides by 1 over 40. T would just be equal to 0. Here we have 1 over 10. T is equal to, take that over, becomes positive 1. And now you're just trying to solve. So the 10 is in the denominator. To get rid of a denominator of 10, you just multiply by 10. Okay, so that 10 will now cancel with this one. And so what we just have is t is finally equal to 10 here. So these are the two values of t we get. And it's okay that we get two values because we have two turning points. We have a maximum and a minimum, but remember which one we're looking for. Okay, we're looking for the minimum. So looking at 0 and then t equals 10, which one would be, so I drew this completely wrong. Okay, so how this should have been drawn, I should have actually just taken this and then put it like this. So that maximum, okay, of 1, this is where it happens. Okay, here. Okay, so between 0 and 10, which one are we looking for? We know we're looking for the lowest level, okay, the minimum. And so we're going to take the 10 because you see how it's going to be more to the right. Okay, so this will have an x value or t value of 10, and then that is the one with the 0. Okay, so the lowest level, we just found the value of t at which it is a minimum. You still need to find that minimum value. Since this is the x value, substitute it into the equation of your cubic function, and you're going to get the y value that goes with this. Okay, it's not the 0. Okay, so we know that we're going to take the 10. Remember what the question says. It says when, okay? It doesn't really ask us to calculate the lowest level. Okay, so yeah, I almost said the lowest level. I was going to take the actual lowest level. They just said when will it reach that lowest level? And it's going to be after 10 days. So you can finally just tell them that. then we're not going to use this one. It's this one. So you can just tell them it will reach the lowest level after 10 days. And that is our answer. Okay, moving on to the next question. Question 9.3 says, calculate the value of T for which the rate of change of oxygen content, okay, so the rate of change of oxygen content is a maximum. Okay, so when they refer to rate of change, the rate of change, you can also see this as the gradient, okay? This is the change in oxygen level as the time progresses. So when referring to this rate of change, the function they're referring to is this C prime of T. So we need to find the value of T for which this is going to be a maximum. Okay, let's just look at what we have here. Okay, so I'm going to take this graph, and yeah, now looking at this graph, I think I just drew it a little wrong because, we're looking at the oxygen level, right? Okay, so the oxygen just reaches different levels. So you wouldn't expect that level to become negative. So an easy way to do this is we can actually just find out what the oxygen level is at 10, okay, since we know this is where the minimum happens. Okay, so do you see what the oxygen level will be like? 0.58. Okay, it doesn't actually reach negative. So I would have to actually pull this down. So around here, let's just adjust the way this looks. Okay, so this is just really an idea of what it's going to look like. This is the minimum that we have here. So we're looking at this, right? And we're trying to find its maximum. There's a little bit of a problem there. Because with this function, do you see how the value of A, right? This is the value of A here. I took the final updated function. The value of A, ax cubed, okay? It is a value greater than 0. So it makes this type of cubic function. If you derive this function and you try to graph it, it will create a parabola. But it's going to create a concave up parabola where A will also be greater than 0. Okay, because you're saying a positive times a positive. It's just going to give you a positive number. And so this kind of function, if you're looking for its maximum, doesn't have a maximum if you just look at it like this. It has a minimum value. So here's what I think they meant. They either meant minimum, or we can look at it from another direction. So I'm actually going to put two answers here. I'm not sure which one they meant. I feel like it's a trick question now at this point. Because do you also remember how in the beginning they did tell us that T goes from 0 to 15, right? So let's keep that down here. Okay, so from 0 to 15. Here is two explanations that I'm going to give, just depending on what they mean. If they meant is a maximum, because we see that, if you're looking at that, okay, the function that the gradient creates. Okay, if you find the gradient of the function, this is C prime, right? It's going to create a concave up parabola. And so in this case, we would be able to find the minimum value. So I'm going to put down two methods, not really methods, but what I think they meant. Okay, if they actually meant minimum, this is what we will do. And then if they meant the other case that I'm thinking of. Okay, so if this is what they meant, then you're simply just going to find that minimum value, and you'll find it because once you have the parabola drawn down, then you can see that the lowest value that this graph, this parabola will reach would be over here, which is at the turning point of the parabola. And here I'm just going to draw it like this. So it's going to cut, the parabola is going to cut 0, okay, and 10. These are going to be your x-intercepts. Okay, so this is how it always works. The x values of your turning points will be the x-intercepts of the derivative of that function. So if this one is C and this is C prime, then that is what we have here. These are the x-intercepts. Then to find that turning point of the parabola, that would be right in the middle. If you have these two values, the x-intercept, then it's going to be at the midpoint of them. Okay, we actually did something like this in this paper. So we can see that this would be at t equals 5. That's where we're going to have that minimum gradient or that minimum rate of change. So really here, if that was the question, if they meant minimum, then all we're just trying to find is the value of t for which this, okay, reaches the lowest value or reaches a minimum. And then that would just be the x value of your turning point. So you would just say to find t, I'll say 0 plus 10 and then divided by 2. and then t would just be equal to 5, and then that would be it. Another way to do this is, it's a longer way, I would avoid that. The longer way would be to take this, okay, you find the derivative of it, and then you know that to find that t value, okay, the turning point of the parabola, okay, that turning point of the parabola is also going to be the x value of the point of inflection, okay, and you know that to find that point of inflection, this is where the second derivative is equal to 0. So in this case, we'd say the second derivative is equal to 0, and then you'd solve for t, okay. So that would be a longer method. But here, if they meant the word minimum instead, then it would be t is equal to 5. But here's the thing. They may not have meant minimum. And here's why I'm saying this. Because do you remember that they gave this restrictions? Okay, they said t goes from 0 to 15. So here's what I mean by this. I know that the minimum gradient, right, it happens at t equals 5. We know that now. But what if they didn't mean minimum and they actually just meant maximum, but you need to take into account that t goes from 0 to 15? Well, then you're going to have to look at this graph and see where does it reach the highest gradient, okay? Where do we have a maximum gradient? If this represents the gradient of the function, okay, we'll look at it from 0 to 15. Where will the highest gradient be? You can see here, this is where the gradient is going to be at the lowest, the gradient of this function, basically. But I'm saying that this represents the gradient. So if you just look at the different levels that you have here, I can just extend this line, okay? If you look at this, you see how low this one is, then the gradient is like that low, okay? Whatever that number is, we'll just say that is the gradient. Then, if you look at it, then we can just look at what the gradient does after 5. If you look at the gradient, right, the gradient function, then do you see that where it will reach the highest would be wherever we cut off, because then this graph is just going to keep increasing, okay? And then somewhere there, wherever it reaches 15, at t equals 15, this is where that gradient is going to be at the highest level, whatever that number would be. Okay, so a way to do this is you can actually just look at the gradient functions separately and just see these as these are the different levels of the gradient, okay? So at this point, this is where the gradient reaches its lowest. Then you can see what the gradient is doing throughout here. And then the cutoff point would be 15. That would be where it reaches the highest point here. Okay, because they cut it off at 15. If there were no bounds though, if they didn't give us any of these bounds, then we couldn't find a maximum gradient because there would be no such thing. It will just keep going up to infinity. So that's why I'm saying they either meant minimum, or maybe they did actually mean maximum, but because they gave us bounds, okay, they said it can't go past 15 and it can't go lower than 0, then yes, the highest gradient would occur at 15 because this is where this would reach its highest, okay, since it's cut off at this point. So yeah, so I have two answers for this. I don't know what they meant, but I'm just going to keep those there. So if this was actually just a trick question, just so that you don't have to like do that whole thing and you have to think about the bounds, then here t would be equal to 15. Okay. Hey guys, this is me editing. I don't think I was too thorough with this explanation, so I just want to say this again. Remember how this is now, okay, now it still represents c prime, okay? So that is the gradient of our function. And so because of that, when we're looking at the gradient at different levels, you can see what the gradient is, okay? So now we can just focus on the y values of it. We're looking for where the gradient would be at its highest. Because the days start from where t is equal to 0, would start from here, and then you can see it goes lower and lower and lower, and then reaches the lowest level, and then you can see now that gradient is now going higher, okay? We have higher gradients all here. And then because 15 is the cutoff point, okay, if 15 was not the cutoff point, like we had something like 16, then you know that you would have a higher gradient at 16. But because 15 is the cutoff point, then this is where we stop. Then this would be the highest level that that gradient reaches, okay, if we look at it from the point of view of a graph. Okay, and so that's really how that works. So I just wanted to explain how you would look at that. You just have to look at this as the gradient of that function at different levels. Okay, so at 0 days and now at 1 day, then the gradient was here. The rate of change was this amount of units per day. Okay, and then here it was at whatever this gives us. Okay, Okay, so if I actually use the gradient, I'm trying to check that gradient there. The rate of change, can you see it is 3 over 16, or you can say 0.1875, okay? So it's a positive gradient. So the oxygen level was increasing by 0.1875 units per day at that point, okay? And then we can look at it at different points as well. You could try at 1 and just see what that is. Okay, it's a negative value. And then if you try it at 0, you see what this is just going to be 0 at the end of the day. Okay, so that's just going to be 0. So the highest rate of change, the highest gradient would be here at 15 days. Okay, so that is it for that. I just wanted to elaborate on that. Okay, so when the memo comes out, we'll see what they meant by that. So that is it for this question 9.3, and that is the last question for question 9, and that concludes it for calculus. And I hope to see you guys in probability.